Okay, a very good afternoon to Doctor and all my friends. Okay, so basically today I'm gonna. Okay, so we have an assignment that here. The assignment that I should do actually is in fluid mechanics. Doctor asked us to do this the video. This is an individual assignment, and we need to create actually a 10-minute video presentation. Actually the maximum 10-minute video, and so we need to explain the liquid characteristic and dimension analysis. And in the dimension analysis there are two methods, which is Rayleigh method and Buckingham's pi theorem. So each of the method we need to give an example in real application in fluid mechanics. So let's start this thing. Okay. Let go. Okay. Yes. Okay. So we're gonna start with fluid characteristic and dimensional analysis. And yeah, my name is Muhammad Ibrahim. My mentor number is 198178. Welcome to my video. So this is the contents that in the video, in the slide actually, I presented in the video. So we have I'm going to talk about fluid characteristic. Second, I'm going to talk about dimensional analysis, and also the example of dimensional analysis. I mean the method that we use in dimensional analysis, which is Rayleigh method and Buckingham-Price method. Next, okay, so in fluid characteristic, what is fluid characteristic? So here it's stated that fluid is defined as a substance which can flow. This is like a liquid. Technically, the flow of any substance means a continuous relative motion between different particles of the substance. The continuous relative motion between the particles of the fluid when shear force is acting on them. The particles of fluid move past each other when shear force is applied because they cannot resist the shear force. They are inelastic to shear stress, so a fluid can deform under shear stress indefinitely without returning to its original position. Okay, so there are two types of liquid or fluid here, which is in the gas and also in liquid. So in gas, it occupies the complete space available in the container and is actually in a compressible volume. So for liquid, the volume remains definite even as it takes the shape of the surface on. So this like the gas, this means that the gas occupies the complete space in the container, like if the shape of the container is like square or rectangle, cone, it's occupied all of it. Like liquid also, like it's gonna follow the shape of the container together, just the volume. So we have four fluid characteristics here. First is specific volume, the ratio of the volume substance to its mass, then specific volume. So it is reciprocal of density and an intrinsic property of matter. Specific volume is defined as the number of cubic meters occupied by 1 kilogram of substance. The unit is meter cube per kg. Okay, the second is specific weight. The weight per unit volume of a material. So in fluid mechanics, specific weight represents the force exerted by gravity on a unit volume of a fluid. Unit are expressed as force per unit volume, like Newton per meter cube or pound per feet cube. Okay, next is viscosity. So this is like the fluid property that determines the amount of resistance of the fluid to shear stress. It is property of the fluid due to which the liquid offers resistance to flow from one layer of the fluid over another adjacent layer. In a liquid, viscosity decreases with increase in temperature. In a gas, viscosity increases with increase in temperature. So the last one is density. The mass per unit volume of a liquid, mass of the volume, is ratio between the mass and the volume of a fluid. So density is essentially in kg per meter cube, or we can also in gram per cm cube. In general, density of fluid decreases with increase in temperature. The density of the standard liquid water is 1000 kg per meter cube. So next, we're going to talk about dimensional analysis. So what is dimensional analysis? Is actually a means of simplifying a physical problem by appealing to dimensional homogeneity to reduce the number of relevant variables. The analysis involves the fundamental units of dimensions like MLT, mass, length, and time. It is helpful in experimental work because it provides a guide to factors that significantly affect the studied phenomena. So this we can see here, the box is here, presenting and interpreting experimental data, conjecturing the equation, and taking problems and not amenable to a direct theoretical solution and physical modeling. So, dimensional analysis, as we talked about, there's two methods, which is Rayleigh method and Buckingham-Price method. So, Rayleigh's method, an elementary method for finding a functional relationship with respect to a parameter in interest, is the Rayleigh method. This form of dimensional analysis to express a functional relationship of some variables in the form of an exponential equation is named after Lord Rayleigh. Buckingham's pi theorem states that if there are n variables in a problem and these variables contain m primary dimension, for example MLT, the equation relating all the variables will have m n dimensionless groups. Okay, so we're gonna go deep into the Rayleigh method. So first, we're gonna gather all the independent variables that are likely to influence a dependent variable. So if the R is a variable that depends upon independent variables, R1, R2, R3, Rn, then the functional equation can be written as R equal to F bracket R1, R2, R3 Rn close bracket. So then write a equation in the form of R equal to C R1A times R1B times R1C times Rnn, where C is a dimensionless constant in A, B, C m are arbitrary exponents. After that, express each of the quantities in the equation in some base units in which the solution is required. By using dimensional homogeneity, obtain a set of a simultaneous equation involving the exponent a, b, c, m. Solve this equation to obtain the value of exponent a, b, c, m. Substitute the value of exponent in the main equation and form the non-dimensional parameters by grouping the variables with like exponent. Okay. So this example, I hope you can see it. Okay, so next is Buckingham pi method. First, we're going to gather all the independent variables that are likely to influence the dependent variable. If R is a variable that depends upon independent, okay, this is actually the same as the Rayleigh method. Okay, this one is a little bit different. Found the number of the variable and dimensional equalities and number of pi group. So pick the repeater that obey the rules. DVP. Density volume. I'm not sure. Express N1 in terms of the repeaters in terms of N1. This is pi 1 equal to R1 X R2Y R2Z dot 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 RMN where X Y Z and are the arbitrary constant. Step 5 are repeated according to the group, the number of pi group. So substitute the values of exponent in the main equation and form a non-dimensional parameter by grouping the number with a like exponent. So this is the example of the the Buckingham pi method. Okay. So that's all for today. Thank you for watching. Hey, what the fuck? Please cut that. Ah, shit.